Hello, this is Dr. Strickland. In this video, we will finish up our investigation of the addition of water to an alkene and start on the addition of an alcohol to an alkene. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So we're going to start with the mechanism of the reaction that we were talking about last time, the addition of water to an alkene. And so, if you're doing flashcards, I would certainly put this on there. The intermediate is a carbocation, and it is a regioselective reaction because we will have, by the end of this chapter, we will have electrophilic additions that have different kinds of intermediates and that may or may not be regioselective. And this will help you to remember the steps that are part of this mechanism. All right, so we're just going to take this general alkene, and I'm going to put the hydrogens that are attached to these two vinylic carbons kind of up and out of the way. Now, the thing that actually donates a proton in this first step is the hydronium ion. So, well, where did the hydronium ion come from? Because this is, an alkene plus water and an acid catalyst, and indeed it is. Whenever you have a strong acid that reacts with water, strong acid is 100% ionized, and what that means is that this reaction goes 100%, and you get the conjugate base of the proton donor and the conjugate acid of the proton acceptor. And in water, this is the actual proton donor. Now, then you have two options when you do this first step, and one is going to be to use the hydronium ion, and I'll show you the other one when we get there. So what's going to happen here is we're going to have a first step where the electrophile adds. And so that's just like all the rest of them. The arrow starts at the pi bond, goes to the partially positive hydrogen, and then this bond between the oxygen and the hydrogen breaks, and those electrons go back onto the oxygen. All right, so what that means is now you have to decide whether the positive charge goes here or here. So pause the video, draw in, where did the new hydrogen go? Where's the positive charge? And then come on back. All right, welcome back. So the hydrogen is going to go to the vinylic carbon that already has more hydrogens so that you can get the more stable carbocation. And then you know that when this donates that hydrogen, that acidic hydrogen, what's left is water. So water is the nucleophile. Now, one of the things that you need to know about nucleophiles that are uncharged is that they are going to make intermediates that have a charge. So when we form a bond between that oxygen and that carbon, these two hydrogens come along, which means it's got one too many. If you look at the general reaction pattern, this is not the end. I'm just going to tuck that down. So what happens here is there's plenty of water in here. And so a second monopole of water comes along and acts as a base. And so now you have this. Plus the hydronium ion. And so now you can see this is where the acid catalyst is regenerated. It was used up here, and then it came out here, and that's the definition of a catalyst. It does not remain as part of the final product. It comes out again to be reused. Okay, so this is where the electrophile adds, if you like to annotate your steps. This is a nucleophilic attack, and this is a deprotonation, taking off hydrogen cation. All right, so we're going to take a very short step from the addition of water to an alkene to the addition of an alcohol to an alkene. So in the acid catalyzed addition of an alcohol to an alkene, the final product is going to be an ether. When you add water, the final product is an alcohol. Okay, you can see it right there. And what kind of an ether it is depends on the kind of alcohol that you use. The reaction runs exactly like the acid catalyzed addition of water, except the nucleophile is an alcohol instead of water. All right, so this runs by Markovnikov's rule also. And so we're going to have, if we've got an unsymmetrical alkene, we're going to have a less substituted vinylic carbon and a more substituted vinylic carbon. And it doesn't matter what color you use, as you use two different colors if you want to do that. And so then, the alcohol shows the pieces that you're going to add to these different things. So the carbon that has fewer hydrogens is going to get the hydrogen, and the carbon that has more hydrogens will get the hydrogen. The carbon that has less hydrogen will get this piece right there. Okay, and so you can see that here in the general reaction pattern. All right, so I want you to come on down here with me, and we're going to use this to predict the major products of these two. All right, so we've got our more substituted and our less substituted. I've got them backwards, don't I? Okay, so this is the more substituted, and this one is going to be the less, and now I'm going to have trouble with it. Okay, so now they're both going to be orange. So let's do this. Less substituted here because it has one hydrogen. More substituted here because this vinylic carbon is bonded to two carbons. Okay, so the more substituted carbon is the one that's going to get the alkoxy group. And the less substituted one is the one that's going to get the hydrogen. All right, so that means that the hydrogen goes here, and that, in a skeletal structure, you won't see that. But the H plus went here. Okay. All right, so what about if you wanted to go the other way? How could you prepare this ether from an alkene? So now this is a target. Okay, so we've got this piece that had to have come from the alcohol. So some sort of alkene. And then we need to know what the alcohol is, and it needs an acid catalyst. And we're going to make this. All right, so the alcohol is just this with a hydrogen on the oxygen. And the alkene had to have been cyclohexane. Now you could draw the double bond there, or you could draw it there. It wouldn't make any difference at all. Okay, so let's take a look at the mechanism of this. The mechanism runs exactly like the one that involved the acid catalyzed addition of water. It's just that we're using an alcohol instead of water. And so because of that, let's do a parallel equilibrium. If there's no water in here and it's the alcohol is the thing that you've got an awful lot of, then we end up with the same sort of things, the conjugate base of the proton donor, the conjugate acid of the proton. And you can put the positive charge here or right on top of the oxygen, where it belongs. But this is the thing that actually transfers a proton in that very first step. So let's see how this goes. So here's our unsymmetrical alkene, and these general reaction patterns are done with unsymmetrical alkenes. They would work with symmetrical alkenes also. So there's your thing that's going to transfer a proton in that first step. And then you want to make the more stable carbocation intermediate. So all these atoms that were originally there are there now. The new hydrogen goes to the vinylic carbon, less substituted, so that the carbocation can form on the vinylic carbon that is more substituted. And then the alcohol comes back in as the nucleophile. Right ahead. All right. Then, since we had an uncharged nucleophile, it's coming with both of those things and still got a positive charge to it. And I think I'm going to do an R prime here just to say that they could be the same or they could be different. And we'll just tuck that back down. And then, like we did before, a second molecule of the alcohol would now act as a base to deprotonate this thing and give you the final uncharged product. In most cases, the final product will be uncharged. All right. Now, one other thing that you will see is that you'll see you may see sulfuric acid written like this, and then this donating a proton, and then you end up with the SO4H minus anion. You can do that. I think this makes a lot more sense, and so I would do it that way rather than this way. All righty. So that's a story on the addition of an alcohol to an alkene. If you have any questions, please send them to me.